Hey, good morning, everyone. Can you all hear me?
I can, yes, sir.
Okay. All right, so hope everyone had a good weekend. I have up here on the screen a display of the grades for this test. I know it's a little confusing here. Really, if you just look at the gray numbers here and the gray dots, that's the grades on exam 3. So they were pretty good. Our class average on that exam was an 82.8. So about an 83. The previous exam was an 83 average. And then the first exam, the average was almost a 90. So I think it went pretty well. Everyone above this green line got an A. Everyone above the yellow line got a B. Everyone above the red got a C. And then anyone below the red, of course, didn't pass the test. So you should have a good idea now of where you stand in the class. We really technically only have, let me see, let me look at our schedule here. I think we have another exam scheduled, but I'm thinking that it's going to be hard to squeeze that exam in here. Let's see how things go, especially because I'm not going to be here on Thursday. Let's see how this exam goes. If we don't, I don't want to take an exam and then like 2 days later take the final. So what I would rather do is basically just give you the final. And then what I'll do is I'll make your exam 4 grade, whatever your highest exam grade was, I'll just replace it with that grade. Does that make sense? So like if your highest grade is a 90, exam 4 becomes a 90. If your highest exam grade is your final exam, then it'll replace exam 4 with whatever that you get. I think that will benefit everyone in the class. Any questions on that? No? So in terms of classes, we have today, Tuesday, November 9th. Thursday, I'm going to be out of town, but I'm going to give you all a short video to watch with a couple of problems to do. So we have today, we have Thursday, then we have, let's see, that's 2 days, 3, 4, and then 5, and then this is a holiday, 6, 7. So we have like 7 class meetings left. Is that right? Seems right. So we only have 7 class meetings, and then really one of those I'm not going to be here. So 6 actual Zoom meetings before our final. So we're getting to the end here. Now, in terms of material on the class, we're going to finish up this week. We're going to finish all this material up. So we'll be done with systems of equations this week, which means that we skipped some stuff in the beginning. I'm sure you remember I skipped all this and I said we would do it at the end. Well, we're going to go back and do all this scientific notation, conversions, proportions, things like that. So we will have more material, but as far as the calendar, we're at the end of the material here at the end of this schedule. Okay, any questions? So today we're going to talk about systems of linear equations. Thursday there will not be a Zoom meeting. I'm going to send an email out to the class. In that email, I'm going to have a link to a video to watch, and then I'm going to have, within the video, I will have problems at the end for you to do. And I do intend on collecting those problems for a grade. It'll probably be something that will help your next exam score, so almost like a bonus. But I do need everyone to do it, okay? So that way I can say, all right, the day I wasn't here, they actually learned something, all right? So just make sure you're paying attention to your email. Also, there is a small chance, very small chance that I get stuck out of town because of my wife's medical procedure. We're supposed to come home on Saturday, but if her drains can be removed on Monday, we'll probably stay and just stay and have the stuff removed on Monday instead of having to come all the way home and then late next week go back for the drains. So that should not impact Tuesday's class. It shouldn't, unless they say, oh, the drains will come out on Tuesday. Then we have to make a decision. Do we stay till Tuesday or or not. So I don't know. So just stay tuned to your email. The plan is next Tuesday, I will be here on Zoom just like this. So we're gonna do that. And then a reminder that this Friday is the last day to drop any 16-week class that you're registered for. So I'm not saying this class in particular, just any class for the fall semester. The deadline to drop is this Friday. So you can drop a class by going into the system that you registered in, and you can drop there. And if for some reason you're having trouble doing that, at least email your professor and say, hey, I'd like to drop the class. And at least there's a record of it that you wanted to drop before the drop date. Because if you wait till next week and say, oh, I want to drop, they won't be able to do it. So everyone okay on that? Understand? If you have any questions about your grade in this class, where you stand, you know, one thing you can do is you can go into Canvas, you can go into your grades. And I believe there's a like a what if thing you can do where you can type in your grades for exam 4 and your final to kind of see what your final grade would be in the class. And you can kind of mess with those to see like what you would need to get in the class to get an A or a B or a C or just to pass. So, you know, just mess with that. But if you have any questions, please contact me. I will be out of town, but I will be available. Just, you know, email me or text me through my cell phone or call me. We good? All right. So we're going to get down to business here. We're going to talk about systems of linear equations today. So when we hear the words linear equations, this should sound familiar to us because in the very beginning of class, we actually studied linear equations. So I'll kind of remind you that we can look at linear equations as lines, right? That's what they are, they're lines. So we have, I want us to consider these two lines, all right? We have y equals 3x plus 8, and we have y equals negative 2x minus 7. Right now, as it stands in this class, I should be able to ask you to graph these lines, and you shouldn't have too much of a problem doing so. So let me just remind you how we do that. If we take this first line right here, let's do this one right here. If we were asked to graph that, we'd recognize that it is in the form y equals mx plus b, where m is the slope of the line and b is the y-intercept. That look familiar to everyone? It was this a few months ago, but this is something most students did okay with on the test. So if we graph this, where do we start? Where do we start by graphing this line? What's the first thing I should do?
The
Not the negative
y-intercept.
7.
Yeah, put the y-intercept. So I'm going to count by twos here. 2, 4, 6, 8. Right here, 8. I'm going to put my y-intercept, so I'm going to put a dot like this. Now, to get to the next point on the line, what I have to do is use the slope, right? And the slope is 3. So we have to look at the slope as a fraction. So I'll look at it as 3 over 1. That's my rise divided by my run. So this means I'm going to go up by 3 and to the right by 1. And that's how I get to another point on the line. So be careful, because remember I was counting by twos here, right? So this is 10 right here. This is 12. So I need to go up 3, which would take me to 11. And then to the right 1. I'll count by ones to the right. So here's 1, here's 2. So I go up 3 to the right 1, and I put a dot right there. And then I draw the line. Now, what I want you to remember about this, okay, is yes, we can graph the line, no big deal, right? I mean, it's y-intercept, slope, we draw it, whatever. But I want you to remember when we're learning about lines, the line is actually a visual representation of all of the solutions to this equation. In other words, if I were to look at, let's say, this point right here, this point has the coordinates, well, the x coordinate is 0 and the y coordinate is 8, right? That means that if I plug in 0 for x and 8 for y, this equation should be true. So let me try it. If I replace this equation up here, if I replace the y with 8, it becomes 8 equals, and then 3 times x, so 3 times, I'm replacing x with 0, plus 8. This should be a true statement, which it is, because 3 times 0 is 0, so you get 8 equals 8. Every point on that line should satisfy that equation. So can somebody tell me what the point is right here? Remember how we got to it, right? This point right here, we went up 3 over 1. So can someone tell me the x and y coordinates of this point?
112.
111, right? Because we went up 3 on this, so we added 3 to the 8 to get 11. That makes sense, everyone? So what that means is that, again, if we take this equation and we replace the y with 11, so I'm going to write the left-hand side is 11, equals 3 times x, so 3 times 1 plus 8. This becomes 11 equals, well, let me see, 3 times 1 is 3, 3 plus 8, that's 11, that checks, right? So again, every point on that line should be a solution to that equation, all right? I'm gonna write that down. Every point on the line is a solution to the equation. Y equals 3x plus 8. So I was reading something this morning. This is off topic, but it's kind of funny. I was reading something this morning, and I don't know, it just came up on my feed here. And where is it? I took a screenshot of it because I wanted to. Oh, here it is. Okay. So it's talking about, like, when you're talking to people, I think it was like the 10 phrases to never say, right? And the very first one on this thing was, and it's saying, don't say this, is, does that make sense? Okay, so like if you're talking to a group of people, you know, does that make sense? And I read that and I just, like, my jaw dropped, because I always say that. Like in my class, I'm like, does that make sense? Does that make sense? And it's like the very first thing on this thing of things not to say. So they suggested, instead of saying, does that make sense, to say, what are your thoughts? I'd like your input on this. So what are your thoughts? Everyone good with this? Are we all right? Amara, thank you. Amara, sorry. We're good? Okay, thank you. Yeah, this is nothing new, right? This is nothing new. But we're going to put things together here in a minute, so I just want to make sure you understand this concept. So for this first linear equation that we did here in yellow, this first one, we understand that we can draw a line, that every point on that line is a solution to that equation. Now, for the other equation right here, that's another line, right? It's a different line, not the same line, but I could do the same process, right? So let me go through this one. I'm going to go a little faster here. I have a y-intercept of -7, so I go down, I'll count by 2, 4, 6, 8, that's -8. So I'm going to go to -7, and I'm going to put a dot. And then my slope is -2 over 1. That means I'm going to go down 2 into the right 1. So from this point, down 2 puts me here, and then to the right 1 puts me there. And then I draw a line. And every point on that line is a solution to that equation, right? So, all right, what are we doing today? We've done this, right? There's nothing new here. So here's my question to you, okay? This is what today is about. is there a solution? Okay, in other words, is there a point to both lines or both equations, sorry, both equations? So what I'm saying is there a point, right? Is there a point that would be a solution to this equation, right? But simultaneously, that point is a solution to this equation. I mean, you can tell by just looking that these have different points. They're not the same lines, right? This is a different line than this line. But is there a point or a solution to both equations simultaneously? So visually, what is that really asking for?
Where are
What are
both,
your thoughts?
where are both points on the graph?
Okay. Is there a point that's on both graphs, right? Is there a point that's on both of the graphs?
Yes.
Okay, someone want to rephrase that? Someone want to rephrase that another way? Let me graph both. I'm going to graph both of these again. Here's the first one. Here's the second one. I put them together on one graph so you can see them. What are we asking? What am I really asking you for? Visually.
Is there a point where the two lines intersect?
Yeah, where do the two lines hit each other? See, because wherever they hit each other, right here, you can see the computer already did it for me. It's telling me that if you go to this point, do you agree that that point is on both lines, which means that it's a solution to both equations at the same time, right? The same x, the same y would satisfy both equations simultaneously. So it looks like -3, 1 works. Now the computer did that for us, all right? So let's just check. Let's see. What was it? I already forgot. What was it? -3, -1. Is -3, -1 a solution to both? Well, how do we check it? We have to just bring down each of these equations. So the first equation was this one. The second equation was, and now what we're going to do is we're going to make sure that this point works in both lines, that we get a correct solution. So here, replacing x with -3, y with -1. Let me try it. I replace this y with -1 equals 3 times x, which is -3 plus 8. -1 equals 3 times -3 is -9 plus 8. And yes, -9 plus 8 is -1. So it checks. So that -3, -1 is a solution to the first equation. Now we're halfway there. It has to be a solution to the other one also. So now what I'm going to do is replace the y with -1, then have -2 times -3, right? Because I'm replacing x with -3 minus 7. So -1 equals -2 times -3 is +6. And then I take away 7. And if you take 6 and subtract 7, you get -1. So yes, it checks. Okay. So it is, right? So let's back up. If I give you two linear equations, right? Two linear equations, and I ask you to find the solution to both of them at the same time, that is called solving a system of linear equations. You're not just solving one linear equation, you're solving two of them at the same time, simultaneously. And that's called a system of linear equations. And so what we're trying to find is that point of intersection of the two lines, all right? So what it really breaks down to for us is find the point of intersection of the lines. Okay, that's what it's going to turn out to be. So one way we could do this, see, the computer gave us the answer, right? the computer gave us the answer. So we didn't have to actually go do it and find it. The computer helped us out. So one way we could do this, right, would be to graph both the lines at the same time and then try and find them. So like put this graph on this one and then try and see where they hit each other. The bad news about that is that that means our graphs have to be very accurate, because if our graphs are off at all, like if you draw your line a little too wobbly or something like mine, you're really not going to be able to be precise about it. Okay, so what we're going to do instead is we're going to develop a way of doing this that doesn't require we draw anything. We don't have to do any drawing at all. We're going to solve the system of equations using a method. And there's actually two methods that you can use to solve systems of equations. And I'm going to show you both. I don't care which one you use. Do the one that you're most comfortable with or the one that you prefer. They both work, okay? One of them does have an advantage later on if you do higher math. One method is more powerful, but you know, for here, it's either one's, you know, gonna work for you, okay? Any questions about the idea, the idea or the concept or what we're trying to do? No? What are your thoughts? I'm kidding. All right, so before we do this, I want you all to think about this. If we start with two lines, are we always going to get an intersection point?
No.
Nix, I see you shaking your head. Alexandra, did you want to say something?
I don't think so in the case of parallel lines.
Yeah. Sorry, I'm finishing up.
Okay.
Yeah, what if your lines are parallel? Right, so will we always have a single point solution? Well, we could, right? We just did. Like if I have a graph that looks like this, let's say one line does this, and let's say the other line does this. Then of course we're going to have a single answer, right? That could happen. So we could have one answer. But another scenario, I think it was Alexandra that said this, is that what if they're parallel lines? So what if you have a line that's like this, and then you have another line that's parallel to it? That means they don't ever hit each other. Then we would have no solution here, right? We should have no points. So it's possible to have zero solutions. Any other scenarios? We could have one answer, we could have no answers. What about this scenario? What if I give you a line? Okay, that one. And then I give you another line, but it's the same exact line. So I give you two lines, but they're the same line. This is kind of a weird scenario. It would be kind of dumb for me to do that, right? To give you a line, then give you the same line and be like, hey, where do they hit each other? But sometimes lines look different, but they're actually the same line. The equations look different. Okay, when you look at them, you're like, oh, okay, those look like two different equations, but they turn out to be the same line. So we want to take this into account also. If this happens, then we have an infinite number of solutions. Because don't they hit everywhere? At every point is a solution, every point. Now this case doesn't come up very much, but we do need to take it into account. And this case also over here doesn't come up much. The one that we're really most interested in is this one right here, okay? So I will do examples of this, and then I will show you an example of these two scenarios just so you can see what they look like. All right, you ready? Let's do a problem here. So if I want to if I need a way of telling you that I want you to find where these two lines hit each other. A way of letting you know that I want you to find the solution to both equations simultaneously. And the notation we use for this is pretty simple. What we do, you know what, let's do the problem that we started class with. Let's do, if I want you to find the common solution to two equations, what I'll do is this, I'll write solve, and then I'll draw a big brace. I'll put the first equation, y equals 3x plus 8. And then I'll write the other equation below it, y equals negative 2x minus 7. I believe that was it. Let me just double check. Yeah, okay. That's what I'll do. I just put a big brace in front of the two linear equations, and then I just tell you to solve. And that means you are now going to try and find where these two lines hit each other, if they even do, right? Could you tell me right now, is it possible, are these parallel lines? Look at the slopes, 3 and negative 2, they're not parallel, right? Wouldn't they both have to have a 3 here or both have negative 2 to be parallel? Right, so we know that these aren't parallel, and we also know they're not the same lines, right? Because if they were the same lines, they would have to be parallel, wouldn't they? Two lines, if it's the same line, it has to have the same slope. So as soon as we see these numbers are different, we know we're going to have at least one solution, or we're going to have exactly one solution. All right, so how do we do this? How do we solve this? We know the answer, don't we? The answer is negative 3, negative 1, because the computer told us, right? How do we get to that? Without the computer, how do we get to it? Well, like I said, there are two methods. The first method is called substitution. The second method is called elimination. And it's always interesting when I teach these, because some students love the substitution and they're like, yes, that's what I'm doing. And other people are like, no, I like the elimination more, right? So again, it's completely up to you. So here's how substitution works. If I start to write out the steps, it starts to get complicated. If I start trying to give you just steps, it's better if I show you what to do and then kind of tell you what I'm doing. All right, so the first method, substitution, what we'll do is we're going to take, you get to pick either equation, you pick one of them, and you solve either that one or the other one. You solve it for X or Y, whatever you want. Okay, so I'm going to pick an equation and then solve for X or Y, your choice. You have complete freedom there. Well, look, the first equation is already solved for Y, isn't it? It's already solved for Y. So there's really nothing I have to do other than write the equation down, because it is already, I've picked the first equation, and then, oops, I picked the first equation, and then I solved it for Y, which it already was solved for Y. Make sense? The next step is to substitute that answer that we just got into the other equation. Okay, so what do I mean by that? I mean, take the other equation. This is the second equation, right? The one that I didn't mess with. And we had solved for what? What did we solve for in the first equation? Y, right? We solved for Y. What I want to do is take that and substitute this expression in for the Y right here, and this is the second equation. So I'm going to take the 3x plus 8, and I'm going to replace that Y with 3x plus 8. So let's do it. 3x plus 8 equals, and now negative 2x minus 7. And now what we've created is a new equation, right? But this equation, we can solve for x because there's only one variable in this equation, just x. So we're going to go back to, again, the beginning of this class. How do we solve these types of equations? We get all our x's on one side, all of our numbers on the other side, right? So we've seen this before. I'll add 2x to both sides. I'll also subtract 8 on both sides. So I should get 5x equals -15, because I'm taking -7 and subtracting 8 and getting -15. Last step, divide by 5. And you get x is -3. Wasn't that what the x is supposed to be? -3, right? Okay, so we have now substitute. I didn't spell substitute right. Oh, well. Substitute that answer in for the y, right? And then solved it. And now what we do is we still need to get y. So now what we do is we substitute that answer into the first equation we have. So what I mean by that is, remember up here, we solve for y, right? We solve for y. We know that y is equal to 3x plus 8. We now take this -3 and plug it in for the x. So y equals 3 times -3 plus 8. So y equals -9 plus 8, which is -1. And so you've got your solution written as a point. It is the point -3, -1. All right, what do y'all, well, what do you think? What are your thoughts?
Not too bad.
Not too bad?
Yeah, we just have to remember the steps then, like you're saying.
Yeah, so let's just run through them again. You start out with your system of equations. You pick one of these equations and solve it for either x or y. Now in this problem, they were both solved for y, so it would have been convenient to pick either one. I picked the first one. Okay, so it's solved for y. Then we take that, we plug it into the other equation. We replace that y with this right side of the equation. Solve that linear equation for x, take that answer, plug it into the equation up here that will solve for y, and we'll get the y value. Okay. So I'm debating now, do I work the rest of the problems that we have for today, do I work them all with substitution? Would you all like me to do that? Or would you like me to now show you elimination on the same problem here and then move to the next problem and show you both methods and the next problem show you both methods? What would y'all like to see? All substitution, then all elimination, or same time?
All methods, I think.
You want to see both?
Yeah,
Yeah.
Everyone good with that?
yes.
Okay. Now, when I show you elimination, don't give up on it right away. I mean, because when people like first see it, they're like, wait a minute, I like substitution, it's much easier, and they just stop paying attention. Elimination does have advantages, trust me. All right, but it is a little bit odd, okay? Here we go. So here's how elimination works. What you do, you have the system. It's more convenient if I write the system again. All right. Elimination. Do y'all remember, did I tell you that story about the boy that was in grade school that added up the numbers? Did I tell you that story?
No.
I didn't tell you that story. Okay, if I have time at the end of class, I'll tell you the story. Elimination is a method used to solve systems of equations, of linear equations. It's the more powerful method. It's more powerful than substitution because elimination works even if you have more than two variables in here. Like if you had X, Y, and Z, and you had, let's say, 3 variables in there and 3 equations, or if you have 4 variables and 4 equations, or 5 variables and 5 equations, or 100 variables and 100 equations, elimination is the way to go. All right. And it was developed by this guy named, his last name is Gauss. I'll tell you the story of Gauss if I have time at the end. Okay. Here we go. So elimination. The way elimination works is the first thing you do, all right? The first thing you do is you rewrite the equations. You bring all your X's and Y's to one side and your numbers to the other. So all I mean is, look at this first equation. I'm going to take this 3x, I'm going to move it to the left, write it as negative 3x plus y equals 8. Now I am going to put the X in front of the Y. Like I could have put y minus 3x because I subtracted 3x on both sides, but I'm going to put it in front. And then you do it on the other one. So I move this negative 2x over to the side with the y. I get 2x plus y equals negative 7. Okay. That's the first step. Like I said, don't give up on this just because we had to do that. Don't be like, well, I don't want to do that. Okay. Next step. And this I think is the hardest step because it's hard to, I mean, I could write in words what it is, but let me just kind of explain it first. What I'm going to do is I'm first going to start by looking at the X terms. I have negative 3x and positive 2x. What I'm looking for is to see if there's a way that I could add these together and get a 0. So right now I have negative 3x. Do you all agree that if this said positive 3x, then if I added them together, I get 0, right? But that's not what I have. I have negative 3x and I have positive 2x. So if I add these together, they don't go away. That's what I'm looking for. I'm looking to see if I can make them go away. So that doesn't work. Let me look at the y's. If I add those together, right? If I add those together, are they going to go away? Still no, right? I'll do y plus y, that's 2y. And that doesn't go away, right? However, it would be really easy, right? If this, let's say, was a negative, right? If that was negative, do you agree then they would go away? Okay, so can I make that negative? Yes, I can. Watch. Just watch what I do. Because this is an equation, do you all agree with all equations I can multiply both sides of an equation by the same number? Like I can multiply both sides by 2, or I can multiply both sides by 5, or I can multiply both sides by -1. That's what I'm going to do. I'm going to multiply, and the way I'm going to let you know that I'm going to put a -1 on the outside here to let you know I'm about to multiply -1 through the entire equation. And that creates a new system of equations. I know this seems weird. Just like I said, don't bail on it yet. So I'm going to multiply everything by negative, which changes the signs. It becomes -2x minus y equals 7. Does everyone see that the bottom equation, all I did was multiply by -1. It just changed all the signs. Everything that was positive became negative. Everything that was negative became positive. Now, the reason I did that is because now when I look at it, if I were to put these two together, right, add them up, they would go away, right? They would just vanish. Y, take away y, 0. So this is the next critical step. What we're going to actually do is we are going to add these equations straight down. So add these down. So if I add these together, right, we're adding here, -3x plus -2x is -5x. Y plus -y is 0 equals 8 plus 7, which is 15. And look what you have here. This is -5x equals 15. Wasn't that what we had right here? Didn't we get that over here? We did, right? We had that right here. So what I can do now is divide both sides by -5. Oh, sorry, it was close. It had the negative on the other side, but I'm going to divide by -5 here. And I get x is equal to -3. Same solution. Now, how do you get y from this? Well, what you do is you go back to, and this is the cool thing about elimination, when you want to figure out what the other variable is, you go back and you can pick any equation you want, any of these. Whichever one you want, use it to get y. So I think the one that I'm going to pick is just that first one, the very top equation. I'm going to use that one right there. So I'm going to write it down. It was y equals 3x plus 8. So y equals 3x plus 8. I'm going to replace the x with -3 plus 8, and then you'll get -1. It's actually the same thing we did right there. And so now you know what y is. So the solution is -3, -1. That's elimination. I'm going to run through it again with you real quick, just talking through it. So what I did was I looked at my system of equations. I moved all the x's and y's to one side. I lined up my x's and my y's together. And then I started looking, is there an easy way to make the x's go away? Not really. There was, I mean, there is a way, but not an easy way. Is there an easy way to make the y's go away? Yeah, just make one of them negative. So I multiply the bottom by a negative, change the signs, then we add down. And then this equation, we solve it for x, take that x, replace it into any of these equations and solve for y. Does that make sense? No. So what do y'all think? I mean, what's your opinion in terms of just seeing this the first time? Anyone already getting a preference here to the substitution or elimination?
Substitution.
Substitution? Yeah.
Kind of like the elimination. It's just remembering to choose which problem you want to plug it back into at the end.
Yeah, I think you're really not going to be able to really determine which one you truly like until you see a few examples. All right. So let's do our next example here. All right. So let's think about substitution first. Okay. If we do substitution, the first thing we have to do is pick one of these equations and solve it for x or y. All right, so I'm going to do substitution right here. So which equation do you want to pick? And what variable do you want me to solve for? And why? Someone tell me.
Probably the first one because the y is by itself.
Okay, yeah, I like that. So if you look at the first equation, I think what's being noticed here by John is that the y is actually kind of just sitting there, just kind of waiting to be put by itself. So we could easily just move that 2x to the other side. And that means subtract 2x on both sides. Okay, so that's kind of the first step, right? We picked an equation and we solved it for one of the variables. It would have been hard, it would have been harder, right, to take that equation and solve for x, because we would have had to have divided by 2 at some point. The second equation would be harder to solve for y, but we could solve it for x because, you know, at least it's x. It's not like, you know, a number in front. But this is fine. Let's stick with this. We good, everyone? What's the next step? So that's kind of like my first step, right? I picked an equation. I solved for a variable. In this case, we solve for y, right? What do we do with this? What's the
Plug
next?
it back in.
Plug it into what?
Your equation.
Why?
Which one?
The second equation.
The one we didn't pick, right? We're going to now use that other equation that we didn't pick. So plug into the other one. So let me write the other equation down. This is the one we did not pick. Right, that's the one we didn't pick. And what are we going to replace here? We're replacing the what with what?
replacing the y with the other equation.
Right there. We're going to replace the y with what we got up here. So this is going to get a little bit messy here. We've got negative x plus 3 times, it's 3 times y, right? So I have to multiply all of that, which means you have to put that in parentheses. Equals 5. So that's this equation with y replaced with this blue piece, and the 3 must hit all of it, so it's going to distribute. Now I solve for x. So I distribute that 3 through, I get negative 6x. I get plus 12 equals 5. I put my x's together, negative 7x. I subtract 12 on both sides. So I did this, I'm doing this kind of in my head. I'm hoping you're okay with this. Put these together, negative 7x, subtract 12 on both sides, get negative 7 here, and then divide both sides by negative 7 to get x is what? So positive, right? Positive 1?
+1, yes.
Positive 1. Okay, that completes kind of like the second step of this. Now, what do we do with this x equals 1? Where do we put that?
You plug it into the other equation, right?
Yeah, so now we plug that answer into, well, into which one? Into, remember we solved for y right here? Remember we did that step? We went, took the first equation, solved it for y. Now we know what y is, right? So if someone told me what x is, I can figure out y. So I'm going to always plug this answer into that equation and replace the y, the x, sorry, replace the x with 1. And we should get y is 2. And so as a point, it looks like this, 1, 2. That's the point. That's the solution point. That's where those two lines intersect. Does that make sense? See, I can't stop myself from saying it. All right, just to show you visually what we just did, here are the two lines. Here's the first one, okay? The computer's drawing it. Here's the second one. And you can see from what the computer's done here for us, they have a solution here. They intersect each other at the point 1, 2. And we were able to find that mechanically by hand, right? Okay, elimination. You want to see elimination on this? Of course you do. Okay, so elimination, we're going to write the system of equations. We're going to make sure that all the x's and y's are on one side and all the numbers are on the other side of the equation. So the good thing about the way that this problem was presented to us is that the first step of elimination is already done, right? All the x's and y's are on one side, all the numbers are on the other side. So that's already done. All right, so can I make, I'm going to start looking at my x's. Can I make these x's go away if I add down? Right now, if I add, I get 2x, take away x, that leaves me with 1x. I'd like the x's to go away. Is there an easy way to make these x's go away by multiplying by something?
What
When you
if,
sorry, go ahead.
Multiply
what
by
if
what?
you use -2, right? To multiply the
Yeah, it
second.
would, okay, so what we'd like to have here, right? What we'd like to have here is -2, right? That's what we'd like to have, because then they would go away. We already have the minus, right? We just don't have the 2. So why don't we multiply everything by just 2? We actually don't need the negative. If we multiply everything by 2, just the second equation, not the first one. The first equation remains unchanged, but the second equation becomes negative 2x plus 6y equals 10. Just think about it this way. What you're doing is basically multiplying this through to everything, right? And do you see now you do get these to be opposites where they'll cancel out? Add straight down. If you add these down, it's gone. Plus, if you add these down, 7y. If you add these down, 14. So 7y is 14. Divide by 7. Y is 2. What do you do once you get y? Or once you get a solution, you pick, right? Any equation you want and go solve for the other variable. So I'm just going to go back again to the very first one. I'm going to grab that one, bring it down here. That's going to be 2x plus y is 4. And I know y is 2, right? We just said y was 2. So 2x plus 2 equals 4. And now we just solve this the way we had before. Subtract 2 on both sides, divide by 2, and you get 1. So what are your thoughts on this? Substitution or elimination?
Elimination.
You like elimination on that one? I like elimination on that one.
I like substitution more.
Yeah. So everyone's going to just kind of have the thing that they feel comfortable with, you know? And like I said, as long as we're doing 2 equations with 2 variables, these are pretty equivalent. Once you go past that, though, elimination is just way more powerful. All right, I have another one for you. Okay, so when we look at this, what you should be thinking is, this sucks, right? Because if we try substitution, right, you're going to have to pick one of those equations and solve for one of the variables, right? But which equation and which variable, they all have numbers in front of them, don't they? Which would make them somewhat challenging to solve for. We're going to wind up with fractions. So somebody pick an equation and tell me what variable, and I'll use it. What do you want?
3x minus 5y equals 12.
Okay, so we're going to pick the first equation. What do you want me to solve for? X or Y? I think they both equally suck, but it's up to you.
Y.
You want to go for Y? Okay. So if I were going to solve for Y, I could subtract 3x on both sides. Right? Then what would I have to do to get Y by itself now?
Divide.
Divide everything by -5, right? -5 here, -5 here, -5 here. And this is where things are going to start to get really kind of yucky, because we're going to have Y equals, okay, -3 over -5. Well, that's still a fraction. -3 fits in front of X. And then I have minus 12 over 5, because you have a positive divided by negative, that's negative. We have fractions, right? And nobody likes fractions. That's our first step, right? Pick an equation, solve for a variable. In this case, we solve for Y. We don't have to solve for Y, we can solve for X. What do we do with this? Plug it into the other, right? Well, what's the other equation? We used the first one to get this, right? This equation, negative 2x minus 7 times y equals negative 8. Are y'all seeing how bad this is getting? Because of the fractions, are y'all seeing how this is not good? This is not enjoyable. We have to replace the y right there with that expression.
Is this where we use elimination instead?
Yeah, you know what? I mean, I'm going to keep going because, you know, some people are going to get married to substitution. What I'm trying to get you to do right now is consider divorcing it or being open to, you know, having a relationship with both of these. All right. Because sometimes substitution is the way to go. It's faster, it's easier. Sometimes elimination is the better way. So I just don't want you to box yourself into, you know, what do they say? Paint yourself into a corner. I don't want you to be like, oh, I only do substitution. And then you get to a problem like this and you're like, oh crap. Right? It's just, there's a lot going on here. Do y'all see that? I'm going to keep going though, because I do want to finish this. So if I multiply this through, I have to multiply negative 7 through here. I'm going to get negative 2x. I'm going to get negative 21 over 5x. And then positive 7084 over 5. And then equals negative 8. So when I multiply these together, you have to remember how we multiply fractions. And I'm not going to review that, but this, you just multiply the numerator times negative 7. That's not 85. Why did I put 85? I believe it's 84. Now we have an equation with just x in it that I get to solve. So since this is my choice on how I solve this, I don't like the fractions, you don't like the fractions, I'm going to clear them out, which means I'm going to multiply the left side of the equation by 5 and the right side by 5. Because these both have 5s on the bottom. So I'm going to distribute a 5 here, 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 and then here. So I get negative 10x. I get minus 21x. I get plus 84 equals negative 40. So again, what I did is multiply negative 5 times this. When I multiply, I multiplied 5 by negative 2, got this. When I do 5 times this, the 5s cancel, which leaves me with the negative 21x. And then here the 5s cancel and I just get the plus 84. These I can put together as negative 31x. And then I'm subtracting 84 from both sides. So I get negative 31x equals, what is that? Negative 124, I believe. And then divide through. What's x? Does it go in there evenly or do I need my calculator? Is it a decimal? Is it a nice number? What is it? Yes, no, it's 4, right? Should we get 4? I'm dividing both sides by negative 31.
Yes.
Yeah,
Okay, so x is 4. Whew, turned out to actually be a nice number. Okay, x is 4. And now what do we do with this answer? Plug it into the blue one, right? Into this blue equation right here. So if we plug it in, I take this and I plug that answer in. This is the next step. I take y equals 3 over 5x minus 12 over 5. I replace the x with 4. And when I do this 3/5 times 4, it really, you multiply the 3 and 4 together, you get 12/5 minus 12/5. Wait a minute. Those are the same numbers, right? 12/5 take away itself, you should get nothing, 0. So I have an answer. My answer is that x is 4 and y is 0. Oof. How many places could you have messed this up, right? Aren't there like a ton of places in that problem where you could have made a mistake
Definitely.
with all those fractions and stuff? I mean, that's tricky. So let's do the same problem with elimination. And I think if we do this, you're going to have an appreciation for elimination. Okay, so here we go. You ready? Elimination. So there's no easy way to make the X's go away or the Y's. We still have an issue here, right? Like this is 3X. I would love for this to be negative 3X, right? That would make it go away. But I can't easily turn this into a negative 3 because all I can do is multiply by a number. Same with the Y's. I can't make these because these numbers are off, right? 5 and negative 7. So here's what I'm going to do. All right, this is the trick. I'm going to look at these two numbers, the 3 and the negative 2, or just look at the 2, and I'm going to get their common multiple. So 6 is a multiple of both of those, right? 6. So what I'm going to do is I'm going to turn this 3X into a 6X, and I'm going to turn this negative 2X into a negative 6X. So how would I turn 3X into 6X? Multiplying it by what?
2.
2. Okay, so I'm going to multiply the top equation by 2, but I'm then going to multiply the bottom equation by 3, not negative 3, positive 3. The reason I'm not doing negative 3 is because I already have a negative here. So think about what would happen if I pass this through, right? On the top, I'll get a 6X. On the bottom, I'll get a negative 6X. So my new equation is 6X minus 10Y equals 24. So all I did was doubled all of these. And then I'm gonna multiply all these by 3. So this is going to be negative 6X minus 21Y equals negative 24. Multiply that by 3, that by 3, that by 3. Now I've got 6X and negative 6X, and I can add down. So when I add this down, I get 0. When I add this down, I get negative 31Y, right? Something like that. But look what we get on the other side. These go away. You get 0. So you have negative 31Y equals 0. If I divide both sides by negative 31, I get 0. And now I can take that answer and plug it into any equation I want. So I'm going to go back up. I'm going to grab this first equation, and I'm going to replace the Y with 0. And you get 3X is 12. Divide by 3 and you get 4. Same answer. Much quicker, right? No fractions. Much cleaner. Would you all agree with that? So, you know, with things like this, really it's going to come down to just be open to both, okay? I personally am partial to elimination. I prefer that, but questions? Oh, I was going to show you the graph of those. So here's the graph of both of those lines. And you can see that they hit each other right here at 4, 0. All right, I have to move quickly through the next two. All right. So I'm gonna do these with elimination just because I can be really fast with these. Notice on this system of equations that it would be easy to make the X's go away if I multiplied the top one by 2. Because if I multiply by 2, I'm going to get a negative 6X here, which will cancel with this. So I'm going to go ahead and do that. I distribute this through to all of them. So negative 6x plus 4y equals 20. And then I leave the bottom one alone. And I add down. Uh-oh. What happened? I added down. What did I get? 0 plus nothing again, right? Didn't the y's go away? Equals what? 24? Wait a minute, 0 equals 24? 0 doesn't equal 24, does it? What the hell's going on here? What's going on? What just happened? Would y'all like to see these lines?
And no solution?
Yeah, there's no solutions. Let's look at the lines. Here we go. I'm graphing them for you. Ah, okay. They're parallel, right? They don't hit each other. How do I know that? How would I have known that? Well, it's in the work. At the end, you get something that's nonsense, right? This makes no sense. 0 does not equal 24. This is no solution, right? No solution. These lines never hit each other because 0 doesn't equal 24, at least not today. That's how you know two lines are parallel, is you can do that. All right, what about this problem? I'm going to do the same method, elimination. Let's make the x's go away. Multiply top one by 2. Right? Because if I hit it with a 2, it becomes a 4x. It'll cancel with this negative 4x. So we get 4x plus 2y equals 16. And on the bottom, negative 4x minus 2y equals negative 16. So I didn't change the second one, but I multiplied through by 2 on the top. Now add down. Oh, crap, something's happening here, just like the one before. This is 0 plus this one here. This is 0 equals, wait a minute, hold on. This is also 0. That's saying 0 equals 0, but that's true, right? Isn't that always true? So what does this look like? Because this didn't give me an answer. It didn't tell me x equals 2 or x equals 5. It's saying 0 is equal to 0. So if we graph this,
Solutions.
infinite solutions, exactly. It's the same line. Here we go. See, I graphed them both together there. It's the same line. And so how would you know that it's the same line? Because you get something that's true, right? This was true. This is always true. 0 is 0. Here we got something that was false. It was never true. No solution here. Here we can say infinite solutions, but I want you to think of it this way. Same line, right? It's the same line. Infinite solutions, yes, that's right. But it's the same line. Okay. So it's 10:40 and I think what I'd like to do is give me, and we're going to call it a day. I'm going to put together the video with the problems to do. And what I'll include in that email that I send to you, that'll be hopefully later today, that email, it'll include homework problems for tonight for this stuff. I'm going to give you just a couple of systems of equations to work out. All right. Yeah, let me do that. I might refer you to the packet. I might tell you, like, go to the packet and do these numbers off this page. But I wasn't sure how far we'd get today, so I didn't put something together yet. All right. 10:40. Let's call it a day. I've got a lot of things to do. Right before we started to pack today, we had a water leak underneath our sink. So I have to fix that and then leave. So let me get going on some things here. I would like to tell you the story about that kid, Gauss, but I'll tell you that story another time. Y'all have a great day. Check your email later. Have a great day. Have a great weekend. And be checking your email over the weekend, just in case for Tuesday. Okay, you have a good one.
Thank you.
Thank
Thank
you.
you.
Same.
Good luck.
To you and your wife, safe travels.
Thank you. Polygamy.